Hey guys, welcome back to the shop. My name's Adam. Getting ready to start our next job here. So we're going to do a little bit of spray welding or metalizing, and we've got a couple parts here we've got to build up. And what we have is we've got these two stainless steel sleeves. These go on a prop shaft and they run in a cutlass bearing. I don't have a cutlass bearing handy to show you. In case you don't know, it's a bronze sleeve with rubber on the inside, and that's what these go in, and it's just a guide bushing, and they typically run in water, like salt water or just any kind of marine application. And both of these, you know what happens is sand gets up in here and starts wearing on them after a while. That grit gets in there caught up and it's spinning, and it just wears it down. Very typical for prop shaft or anything like this. Whenever you pull it out of a cutlass bearing, this is what you see, a little bit of rubbing. It's not much. It's like 10 thousandths. This measures 2.5, and you get about 10 thousandths under on that one, and this other one is not quite as much. It's about 5 thousandths. So we're going to use our metalizing technique to repair these. We'll turn these down slightly, you know, undercut them, and we'll build them up using our powder. And I thought I would show you the powders that I'm going to use. Typically what I use is Lubrictech 19985. This is for all your general purpose build-up usage for bearing surfaces, seal journals, and just a lot of your typical build-up surface work there. I use that, and I'm getting kind of low on this. Still got another bottle, but getting a little bit low. So I've got another one here that I could use. This is Tech 19222. I have two of these. These are excellent also, machinable with carbide. But today I think I'm going to use my Metco 41C stainless steel. I've got this jug here filled up and marked so I know which one it is. And this is it's a stainless steel powder. So I've got plenty of it. This jug is full, so we're going to use that on these parts right here. Now how we're going to hold this, I got to do all of the outside right here, you know, right up to this, close to where this key is. This is a 2-inch bore. This is a fully machined part. You got a 2-inch bore in there. Here's a piece of 2-inch chrome rod, and you can fit that in there. Got a nice fit. And both of them are the same way. So what I can do is make a 2-inch mandrel for these to go on. I'm going to use this piece of 2-inch cold roll right here, and we'll cut a piece off. I'll chuck it in the lathe and get it indicated, polish a little bit, get some of this rust off, and this will be able to fit on there just like that. Fits good. I'll have a hole drilled and tapped in the end here so that we can just pull this up with a bolt. All right. And that'll hold it good. And I'll be able to do my turning and spraying and everything like I need to. And may have to drill the bolt for a center. Not sure yet. We'll figure that out once we get to it. I don't know. We'll see. So anyway, that's the job. So let's go ahead and get started on it. Okay, I've got my piece cut. I cut it about 12 1/4 long because what I wanted to do was have this out away from the chuck a little ways. I didn't want it right up here next to it. All right, so I've got it out away, you know, a comfortable distance right here where I'm not blowing up here close to my chuck jaws. The other thing I decided to do, because I want to extend this out, instead of drilling and tapping the end of this for a bolt, I'm actually going to turn and thread it. I've got a 1/2-13 brass nut right here, and I'm going to turn and thread it for a 1/2-13. So we'll slip this up on here, and you'll have a stud sticking through that I'll run a nut up on there and tighten it, and I'm also going to have a center drilled in the end of that. That way I can use my center to support the work here. So that's the reason why I'm going to do the stud method here. I've already got it indicated just to try to speed things up here. Nothing fancy. You can see right here we've got it within a 1/2 thousandths. Okay, so All right, we're gonna go ahead and put a center in it, and we'll start drilling, turning and threading. Okay, I want 1 1/8 inches. That's going to give me about an 1/8 inch clearance past the nut there. I'm just using my hook scale to set 1 1/8 inches. Set me a 0, and we're going to turn it down to 1/2 inch. It's 200 thousandths a cut. When I get down here to the face, I'm going to just face it back. I went in about 10 thousandths on my indicator there. Okay, let's see, should put me about 5 under, 3 under actually. That's good enough. All right, let's get in there. Okay. All right, let's do some threading. All right, time to get this thing threaded. It'd be a 13 pitch, 13 threads per inch. I'm just going to come up close to the shoulder and stop because you're going to have the bushing sitting on it right here. So we'll just come up and eyeball it. All right, so I need to get my cross slide set to 0. Alright, there's 0. We'll touch off on the compound. Alright, there we go. Set that to 0. We're going to be doing an in feed of approximately 57 thousandths. BD7. Alright, BD7. I'm going to hit every other line on the threading dial. Go ahead and check it. Okay, that looks good. That was 40. This is 50 thousandths. And here's 55. All right, let's give that a check. Give it a little file off the top. Alright, still a little tight. I'm at 55 thousandths, so we need to go in a little more. Make a little spring pass here. Okay. Look at that. I'm on 57 on the cross slide. That's actually a very, very close fit. There's no wiggle. It doesn't spin freehand. It's got a little bit of resistance there. So, you know, it wouldn't hurt to, you know, go another couple thousandths for a little bit of looseness there. But I think I'm just going to leave it like it is. I like a good fitting thread. Okay. All right. We'll be back. We're going to set up and start doing our undercutting. Okay, we're going to do a little pre-fit here just to see how they look and how everything fits up. And by the way, Stan, I'm going to use your SK Wayne 13/16 wrench you sent me. Not going to make it super tight here, just going to snug it up a little. Okay, that looks pretty good. I don't think that the outside is machine true with the inside diameter. Quite a bit of run out here on this end here, but we're going to be, you know, we're going to be machining it, so it'll be true once we're done with it. It fits on the prop shaft just like you see here, exactly the same, just about. Slides on and you know, gets bolted on. Fits a 2-inch shaft. Okay, that's about the same way. Now I can see down here that this end that hasn't rubbed, it's running out a few thousandths. Same thing with this chamfer here. So what that's leading me to decide is whoever made these, I don't think they got the inside and outside perfectly centered with each other. And you know, that may not be that big of a deal, a few thousandths. I'm just pointing it out. So we're going to leave that one set up. I'm going to go ahead and run my center up. And I want to give that nut just a little bit more torque there. Get it in low. Okay, that should be plenty tight. Alright, we'll go ahead and start getting some masking put down and get that, and then we'll start doing our undercut. Alright, I'm going to use my old wore out live center. This is the one I use for any kind of welding, heating, or spray welding. It's good to have one of these around and use it just for that. It still works fine though. Okay. Alright, here's my masking compound. It's called Solution 103. And it's made by the Eutectic company. I've had guys ask me about this and I forgot to get back to them really. But this is it. You shake it real good. I've already shaken it up really well because it settles in the bottom. It'll get real thick down here and then it's light on top. See? Use a little paintbrush. Kind of dab it in there like that. Wipe the brush off just like you would paint. And what I want to do is I'm going to coat all this down here really good, even the center here. Now when I'm spraying it, I'm going to back the center out. It's not going to be in there, but I just want it to keep the masking from going up into the center hole. Put some on this chamfer here because we're not necessarily spraying that. Okay. Get a little bit more on here. It's right up to where, right about where we're going to stop our undercut. And then right here where this keyway is milled in here, we're going to put some up in there like that. Okay. Put a little bit more on them threads. That stuff loves to stick to threads. Okay, we're going to let that spin and dry. I'll probably turn my fan on. And don't forget to rinse your brush out as soon as you're done masking, because this will harden up and then you ruin the brush. Alright, we'll be back. Alright, we got our masking on there and we're dried, so we're getting ready to do an undercut. I am using a 3/8 carbide tool there, like a threading tool, kind of honed on a radius. So what we'll do, we'll start off by just touching us a stopping point that I want to go to, and it's just going to be right past the wear mark. We'll say right about there. Okay, a little line there to follow. I'm going to come down here really close to where that chamfer ends. Okay, that looks pretty good right there. I'm going to try to make this in one pass across there. So I'm going to feed in lightly until I can see it cleaned up, and then I'm going to engage the feed. Alright, we're touching off. I'm going to zero it right there. Okay, that's 20 thousandths. Now I'm going to stand back because those are those long stringy chips on non-magnetic stainless. Those things can really hurt you. So I've got my long pliers here, and if I need to, I'll kind of pull them out of the way some. This right here is one reason why I don't like using those kind of tool bits a lot on this kind of metal. It's hard to get it to break a chip. And I don't like these stringy chips. I'm just standing back here behind the camera on the right side of the machine. As soon as it cleans it up, I'm going to stop it and hit the foot brake. Okay, there we go. Now I've got a mess of chips right here I need to get cleaned up. So let me move all this out of the way, and then we'll come back and we got to do an undercut, a thread on the undercut. I got it set to 28 threads per inch. I'm gonna touch off. I'm gonna feed in like 15 thousandths, and then engage the half nut. We'll just make one pass down this piece. Okay, 15. 1 second. I had one of the levers raw. I could tell that lead screw was running way too fast. Okay, now we're ready. CD8's 28. Okay. There we go. All right, that's good, but I want to come down here, and when that thing was spinning, it looked like I had some of this masking up in here. So I'm gonna come in here and clean that up and make sure that there's no masking in there. Okay. All right. We are ready to spray. Let me get set up and we'll be back. All right, here we go. Getting ready to start spraying. I got everything ready. All I got to do is light the torch. And today I'm going to use my Ultra Bond 35,000 for the bond coat, and then of course I've got my 41C stainless ready to go also for our build-up coat. And I'm going to do a little bit of a slight preheat, and I'll touch it with this stick down here on the end. If it acts like it's melting, I'm hot enough to start the coating. It's trying to melt already. Okay, we're going to do our bond coat. With our stainless. quite a bit to come up. Alright, according to the calipers, I've got it built up enough, but with a part like this, you're going to have to deal with shrinkage. So I'm going to turn the fan on, I'm going to let it cool down a little bit, and I'm going to check it with the calipers, and if it shrinks down so much, I might go ahead and put another coat on there. So we'll be back.